From 1964 to 1966, NASA was in absolute overdrive, with the most innovative and groundbreaking manned space program ever devised, Project Gemini, utilizing a two-man spacecraft and a secondary docking vehicle to test and evaluate every technique that would be necessary for the upcoming Project Apollo to complete its lunar objectives. Every single mission tackled something new, something potentially dangerous, and something that could threaten the entire program if it didn't work. One of the most crucial of these was docking, linking two spacecraft together and keeping the combination stable and capable of operating together. In Christmas of 1965, the dual mission of Gemini VIII-6 had proven the capability of the spacecraft to make precise rendezvous and maneuver closely and safely with each other, as well as operate for a full 14 days, the maximum amount of time a trip to the moon would take. It was now time to close that final couple of feet and bring the two together. Unfortunately, two Gemini spacecraft were unable to link up in this manner. NASA needed a special vehicle to accomplish this objective. To this, they turned to the Air Force and a vehicle called Agena. Developed by Lockheed Martin, the RM-81 Agena was an upper stage and satellite support vehicle originally intended for a reconnaissance satellite program. The vehicle would launch atop a booster stage, much like any NASA manned spacecraft, but retain its own rocket engine for boosts into higher orbit, or even potentially beyond Earth orbit. While the reconnaissance program it was originally designed for was cancelled, the vehicle itself proved viable for a wide variety of functions. 3 variants of the craft were flown from 1959 to 1965 for both NASA and Department of Defense satellites, and were capable of being mated to the non-man-rated Thor booster, the Mercury-proven Atlas booster, and eventually the Titan IIIB, the upgraded booster developed to follow Gemini's Titan II. Where Agena becomes important here is with the Agena Target Vehicle, developed from the 3rd generation Atlas D. The ATV, as it is referred to, consisted of 3 components. The forward compartment was designed by McDonnell Aircraft specifically for Gemini, including a cone-shaped docking collar, a clamshell nose shroud that would cover it during launch and subsequently be jettisoned upon reaching orbit, and the auxiliary equipment rack. This rack would house experiments and equipment for extravehicular spacewalk operations intended for later Gemini missions. The midsection was the Agena D main equipment bay, which housed the navigation and control systems for the vehicle, as well as the main fuel tanks. The aft section was also specific to Gemini, with a typical main engine adapted with smaller maneuvering thrusters and secondary engines for supplemental maneuvering during mission. These thrusters and engines would also absorb some of the responsibility for orientation and maneuvering during the mission, therefore providing the Gemini spacecraft with a welcome savings in thruster propellant. The main engine would also serve the purpose of boosting the combination into a higher orbit, not high enough to reach the moon, but enough to prove that a manned spacecraft could indeed perform drastic changes to its orbit in flight. But this was an objective for later flights. The docking objective must be accomplished first, and this was the task given to 2 spaceflight rookies by the name of David Scott and Neil Armstrong. The flight of Gemini VIII would actually be the second time Gemini has attempted to rendezvous with Agena. The first came on Gemini VI, which had to be scrubbed when the Atlas Agena exploded before making orbit, necessitating Gemini 6A to instead use Gemini VII as its rendezvous target. March 16, 1966 would be the second attempt, and after Armstrong and Scott board the Gemini spacecraft, the 3 inline engines of the Atlas booster ignite and send the Agena into the sky. As with the previous Agena launch, the Atlas performed perfectly. 2 minutes into the flight, the skirt separates, leaving the center sustainer engine to boost Agena out of the atmosphere, and once its fuel is depleted, it is cut free and Agena's engine fires to make the final orbit insertion. And this time, it went perfect. Agena's engine fired on time, the nose shroud separated, and it continued through its 90-minute orbit, at which time Gemini's Titan booster sends the 2 astronauts on course to intercept their waiting target. The objectives for the mission were daunting to say the least. While the primary mission objective was to dock with Agena, there were a series of maneuvers and multiple docking approaches that were also to be tested. On top of that, Scott was to perform an extended 2-hour EVA, during which he would retrieve an experiment from the Gemini spacecraft and maneuver over to the docked Agena and activate a micrometeoroid experiment, and finally climb back over to Gemini to test a special power tool on a mock work panel, testing his ability to loosen and tighten bolts in weightless conditions. On top of this, a second EVA after Gemini separated from Agena, requiring Scott to climb to the back of the spacecraft and strap on a backpack maneuvering unit, performing formation maneuvers with the two vehicles. This was to be the first time EVA was to be attempted since Ed White's spacewalk on Gemini IV, which was little more than floating around for 20 minutes. A fully loaded flight plan, all scheduled within a 3-day period. Ambitious, to say the least. As Gemini VIII makes orbit, the spacecraft performed a burn of its own ohms thrusters to lower its orbit apogee slightly. In basic orbital mechanics, the lower your orbit, the less distance you have to travel to complete an orbit, therefore the faster you travel relative to the planet below. With this lower orbit, Gemini began to catch up to Agena from behind. After passing closer to the target, Armstrong performed several more maneuvers to boost their orbit altitude, slowing the approach, and finally sighting Agena as they passed within 76 miles.
Okay, we've got a visual on the Agena at 76 miles. Roger, understand. Visual, Agena 76 miles.
The approach would come to an end at 150 feet when the two vehicles held station keeping with each other. The companion vehicle out the window, practically within reaching distance, was quite a sight for the two astronauts.
Hello Houston, this is Gemini VIII. We're station keeping on the Agena at about 150 feet. Way to go, partner.
Boy, look at that.
That's beautiful. See the dipole?
Do I ever?
Man, that's great.
Man, that is really slick. I bet those Lockheed guys are just jumping up and down.
Armstrong makes small thrusts to take Gemini VIII into a circular path around Agena, inspecting it for any damage, but also to further test the Gemini's incredible maneuvering ability that the previous mission had also performed with perfection. This maneuver continued for 30 minutes before finally receiving the go for docking.
Okay, Gemini VIII, we have cams solid. You're looking good on the ground. Go ahead and dock.
Armstrong lined the nose of Gemini with the docking collar of Agena and made a slow, careful approach. Closing the final distance, the docking nose of Gemini nestles safely inside, latches lock, all lights are green, and just like that, the first ever docking of two spacecraft.
Flight, we are docking. And he's really a smoothie.
Oh, Roger.
Hey, congratulations. This is real good.
But there was still much to do. Houston would need solid radio contact with the spacecraft for upcoming duties, so shortly before Gemini passed out of communications range with Tananarive, Jim Lovell at Capcom passed some housekeeping instructions up to Armstrong and Scott.
Gemini VIII, Houston, Capcom, over. Gemini VIII, go ahead. Roger, 8, reading you loud and clear. I have some information for you. Ready to copy? What kind of information is it? Well, first of all, it's about the yaw maneuver. I have some dope for you, which we'd like you to follow. Do you mean the SPC yaw maneuver? Right, we believe that we have the load in, and we'd like to have you enable the SPCs and let the Agena start counting through. If you run into trouble and the attitude control system of the Agena goes wild, just send in command 400 to turn it off and take control with the spacecraft. Did you copy that? We understand.
At the time, there were suspicions that Agena's attitude control system was not functioning at 100%, or may even have an incorrect program stored in it. This way, should something perform abnormally, the command would shut down Agena's maneuvering system and give Gemini complete control. Shortly after contact is lost, the Agena begins the first of its stored commands to turn the craft combination 90 degrees. As the turn executes, Scott notices something strange. Instead of just a sideways motion, the craft is now rolling. Armstrong used Gemini's thrusters to cancel out the roll, but it would just pick back up again. Something was throwing off their orientation, and the natural assumption was that it was Agena. Utilizing the command that Lovell had reported up to them, Scott transmitted the instruction and the Agena shut down, but the roll continued. And this was dangerous. The Agena was essentially a long booster stage, fully fueled. If the roll rate caused any stress upon it, it could cause a rupture and a catastrophic explosion. Armstrong fought to bring the combination to a stop once again, and Scott hit the undock button. After a burst to back away from the separated drone booster, Gemini began to tumble out of control. Outside the spacecraft, one of the thrusters in the aft section began a constant spray of exhaust. Typically, the thrusters just pulse, and in such a case, a puff could be heard inside the spacecraft. But this puff is only the initial activation. With this thruster shooting a steady stream, no indication of such could be heard, and therefore no determination of exactly what was causing this roll. All they knew right now was that it was, in fact, their spacecraft that was malfunctioning. A tracking station in the Atlantic Ocean, coastal Century, Quebec, began to pick up telemetry from Gemini and Agena.
CSQ at telemetry AOS on Agena and Gemini.
Roger. How's it look?
Well, we're indicating spacecraft 3 here. I'm going to call the crew now.
Say again?
We're showing a spacecraft 3 indicating a non-dock. Let me check with the crew.
Ground control was unaware of the problem until acquisition of signal, at which time Gemini VIII had reached a roll rate of 1 revolution per second, and still increasing.
Gemini 8, CSQ Capcom, contact, how do you read?
We got serious problems here with the forward coupling end over end, but we're disengaged from the Agena. We're rolling up and we can't turn anything off. Signaling increasing in a left roll.
CSQ flight?
Go ahead, flight.
Did he say he could not turn the Agena off?
No, he says he is separated from the Agena and he's in a roll and he can't stop it.
Armstrong watched the fuel gauges and could see that the thruster propellant had dropped to 30%. At this point, it was clear that there was a constant thruster activity which was causing the spin. Initially, he perceived this as his flight control stick being stuck in one direction.
In a violent left roll here at the present time. We can't harm ours. RCS is armed and we can't fire it. We currently have a roll, a stuck hand controller.
Roger.
Did I hear a stuck hand controller?
That's affirmative, flight. You seem to have a stuck thruster. They have initiated the squids and blown them, but they can't seem to stop it or get them working.
Naturally, they had no way of determining exactly what was causing the thruster to continue its erratic stream, but the clear solution was to shut down the ohm system. This killed the thruster and prevented the roll from increasing, but they were still stuck in a tumble, and now lacked maneuvering control to cancel it out. There was only one solution left: the re-entry control system. A set of thrusters on the nose to be used for controlling the spacecraft orientation during re-entry.
On a flight, this is CSQ. We can't seem to get any valid data here. He seems to be in a pretty violent tumble rate.
Roger. What about the Agena?
We're showing ACS off on the Agena. We've lost considerable gas pressure and it's way down.
Okay, we're regaining control of the spacecraft slowly in RCS direct.
Roger, copy.
We're pulsing the RCS pretty slowly there so we don't it's our roll right. We're trying to kill our roll rate.
Okay, fine, keep at it.
It would take 75% of the re-entry fuel to finally stop the spin, leaving the craft with only partial fuel for re-entry, and no operational maneuvering thrusters for orbit. Mission rules state that if the RCS is used for any reason, the mission must be aborted. But even without this rule, the situation was academic. Gemini VIII could no longer accomplish its remaining mission objectives. For safety's sake, they waited one orbit before re-entry, not only to verify the emergency program, but to allow recovery forces extra time to reach the touchdown point that was not originally planned for. As Gemini VIII splashed down, Armstrong and Scott had to wait approximately 3 hours for recovery forces to arrive, the two Air Force pilots growing a little seasick in their cramped cabin bobbing in the ocean waves. Beyond a bit of stomach discomfort and mild exhaustion, The two astronauts were recovered in good condition, suffering no ill effects from the violent spin. A press conference was held immediately after the mission, even before the official investigation of the spacecraft could begin. Naturally, audio records of the flight were provided to the press for review, but NASA even took the extra step of including the flight director's loop on top of it. In many cases, the press knew more, having listened to the tapes before the conference, than the officials involved who only recall from their memory of the incident as it happened. During the investigation, ground controllers also reactivated the Agena and tested its systems in various on-orbit maneuvers until its fuel and power supply were finally depleted. No conclusive cause of the thruster malfunction was determined, particularly since the service module was jettisoned before re-entry. The determination was that there was most likely a static discharge, causing an electrical short in the thruster. And with this constant flow of power, the thruster continued to fire even as it was inactive. As a preventative measure, each thruster in all future spacecraft would have an isolated circuit so they could be activated or deactivated individually. If such an incident were to happen again, the malfunctioning thruster could be individually shut down, allowing for the mission to continue with the remaining jets operable. A flight that was intended to last for 3 days, instead lasting only 7 hours, and subsequently abandoning a long list of mission objectives. Even so, the primary docking objective was completed, and Gemini VIII had become the first manned spacecraft ever to accomplish this feat, and the first manned spacecraft to abort during orbit. Facing extreme adversity and stress, the two astronauts remained calm and resolute, saving the mission from potential disaster. The quick actions of Neil Armstrong and David Scott, possibly even saving the space program itself as a result. Both men would go on to make history, as Scott would fly as command module pilot of Apollo 9, and later walk upon the moon as commander of Apollo 15. And of course, Neil Armstrong will forever be remembered as the first man to step foot upon the lunar surface in the flight of Apollo 11. Together on Gemini VIII, they tested and proven a critical phase in making their eventual trips to the moon possible. A moment that will forever mark this week in space history.